Test tomorrow on 7.1, 7.2, and 7.4. It's 10 questions, no calculator. But you'll get the unit circle, you'll get the trig identities for simplifying your trig functions, and you'll get the sum and difference formulas. I picked a few that I want to go over on the review. If we have time, I'll do more, but I want to make sure we get through these. So starting with number 35. So we always want to isolate our trig function, get the trig function all by itself. So what should we move to the other side first? So let's add 1. We'll move it to the other side. So 4 cosine squared is equal to 1. Then what? Divide by 4. So cosine squared is equal to 1/4. How would we get rid of the squared part? Square root both sides. What do we have to remember to do when we take the square root of both sides? Plus or minus. Now we can think about this as the square root of 1 over the square root of 4. What's the square root of 1? 1. And what's the square root of 4? 2. So this would be plus or minus 1/2. Now cosine tells us we look at what? The x value. Awesome. We want to see where on our unit circle do we have an x value of positive or negative 1/2. So we'll go to our unit circle. Where do we have an x value of positive or negative 1/2? 2 pi over 3. Yep, that works. We've got negative 1/2 there. Where else? Pi over 3. We have positive 1/2 there. Anywhere else? 5 pi over 3. Yep, positive 1/2. And 4 pi over 3. Perfect. What do all of our answers have in common? They're all over 3. So that'll be a similar pattern. When you're looking for the same number, it'll have the same denominator. So our x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So those are our 4 answers here. Any questions there? Nope. You just look at the unit circle, find your answers, that's it. 36. We have cosine of x times cosine of x minus 1 equals 0. So here, it's actually factored for us. Sometimes we might have to factor where you have a squared term and a not squared term, can't combine them together, so you'd have to factor. Sometimes you can factor by taking out the GCF. But this one already factored for us, so we can just set them both equal to 0. So cosine x equals 0. Cosine x minus 1 equals 0. So cosine x equals 0 is already solved. The other one, when we isolate our trig function, we get cosine is equal to what? 1. Awesome. We add 1 to move it to the other side. Now cosine tells us we look for what on the unit circle? The x value. So starting with the first one, let's see, where do we have an x value of 0? Pi over 2, our x value is 0. Perfect. Where else? 3 pi over 2. Awesome. Our x value is 0. So we'll add those two answers. We have pi over 2 and 3 pi over 2. And then let's do the same thing here. Again, it's cosine, so we're looking to see where we have an x value of 1. Where do we have the x value of 1? At 0. Perfect. So this would be 0. So these would be our 3 answers here. 37, we want to isolate our trig function. So I'm going to subtract square root 3 to move it to the other side. Since it's being added, we do the opposite. Now tangent, we look for what on the unit circle? Awesome, y over x. So we have to do a little bit more math here. I need to see where do I have a y over x that equals negative square root 3. So we're going to go to our unit circle. I'm going to erase what we have here already. Now, it already gave us the tangent for the first quadrant. This isn't going to be given to you, so this part is not going to be given on the test. So you can come up with these by just dividing the y over x. I'm going to cheat a little bit on this question because I see that at pi over 3, the y over x equals square root 3. So I know that like this is kind of similar to my answer. What did we say y over x has to equal? Negative square root 3. So that's what we're looking for. Where does y over x equal negative square root 3? To find that, because remember this isn't given, we can take our y. So from this point, I'm going to take the y value, which is square root 3 over 2, over the x value, which is 1/2. What do we do when we have a fraction and a fraction? Keep, change, flip. Keep the top, change to multiplication, flip to 2 over 1. The 2's cancel. So this would be square root 3. So we can always find it that way because it's not going to be worked out for us. But you can work out the first quadrant. Since it's square root 3, it's the same number but not the right sign. But what's the denominator in my radian here? 3. So I know that my other answers will have a 3 in the denominator. So those are the ones that I want to look at. Everything with a 3 in the denominator. So if I did y over x for 2 pi over 3, that would be square root 3 over 2 over negative 1/2. When we keep, change, flip, does that give us negative square root 3? Is that what we were looking for? Yeah, so that works. So this would be one of our answers. What about for 4 pi over 3? If I have negative square root 3 over 2 over negative 1/2, would this be negative square root 3? What's a negative divided by a negative?
Positive.
Positive. So will that be our answer? No, because it's going to be positive, and we're looking for negative square root 3. Jacob, turn around. And then for the last one, we have negative square root 3 over 2 over 1/2. Keep, change, flip. So the 2's cancel. This would give us negative square root 3. So does that work? Yeah, so 5 pi over 3 also works as an answer. So our two answers would be 2 pi over 3 and 5 pi over 3 because we were just looking for negative square root 3. If it was plus or minus, then all the ones with the 3 in our denominator would work. But since it's just negative square root 3, our answers here are just 2 pi over 3 and 5 pi over 3. All right, so we said that when it is sine, we look at what value on the unit circle? The y value. When it's cosine, what do we look at? The x value. And when it's tangent? The y over x. Perfect. All right, let's do the secant one down at the bottom. So that first one on the left. So I have a secant squared and secant. Can I combine these together? No, they're not like terms, so we can't combine them. How would we solve here?
Put the 2 to the other side.
Subtract the 2 to move it to the other side. So we have secant squared minus secant minus 2 equals 0. What can we do next?
Factor.
Let's factor. So here, our leading coefficient is just 1, so we can factor it like normal. What are two factors of negative 2 that add to negative 1?
Negative 2 and positive 1.
Negative 2 and positive 1. So instead of saying x minus 2 and x plus 1, I'm going to say secant minus 2 and secant plus 1. Now we didn't start by multiplying, so we don't have to divide. We can just set each piece equal to 0. So when we set them equal to 0, we get secant equals what? 2 and secant equals negative 1. Awesome. All right, now secant. Was this one of the ones that we were talking about up here? Is that sine, cosine, tangent? What does secant go with, though? Cosine. Secant goes with cosine. They're the reciprocals of each other. So instead of secant, we're going to flip this to cosine. So if I flip secant to be cosine, I also have to flip the 2 to be what? 1 over 2. Awesome. So it keeps the same sign. If it's positive, it stays positive. It's negative, it stays negative. But you just flip the number. Instead of it being 2 over 1, it's now 1 over 2. We'll do the same thing with the secant here in our second equation. If I flip secant to be cosine, awesome, it would stay as negative 1. Because negative 1 would be like negative 1 over 1. When we flip it, it would be 1 over negative 1, which is what? Negative 1. So it really just stays the same. So you have to flip both sides. Now we have cosine. Ari, cosine tells us we look for what? The x. So where on my unit circle do I have an x value of 1/2? Let's go to our unit circle. Pi over 3. Yeah, we have an x value of 1/2. Where else?
5 pi over 3.
Perfect. So pi over 3, we've got an x of 1/2, and 5 pi over 3, we have an x of 1/2. Awesome. So pi over 3 and 5 pi over 3. And then, again, we have cosine equals -1. So cosine tells us we look at the x. Where do we have an x value of -1? Awesome, pi. Anywhere else? Nope, just pi. Pi is the only place where we have an x of -1. So pi would be another solution here. Bless you. So with number 9, what do we need to do to solve here? We want to factor. How do we factor when our leading coefficient is not 1? Multiply the first times the last. So we get -2. What are two factors of -2 that add to -1? 1 and -2. Perfect. So 1 and -2. Yep, that works. So instead of saying x plus 1 and x minus 2, we're going to say sine plus 1 and sine minus 2. Now, if we start by multiplying, what do we have to remember to do? Don't forget to divide by that first number. So simplify if it can be simplified. If it can't, move it in front of the x or in front of the sign. So we have 2 sine of x plus 1 and sine of x minus 1. So set them both equal to 0. So we get sine of x equals what? -1/2, perfect. And sine of x equals 1, awesome. So I skipped a couple steps there, but just set it equal to 0 and work it out. So we get sine of x equals -1/2 and sine of x equals 1. Sine tells us we look for what? The y. So I want to see where on my unit circle do I have a y value that equals -1/2. 7 pi over 6 and 11 pi over 6. Now next, we have sine of x equals 1. So sine tells us we look at the y value. Where do we have a y value of 1? So we'll add that as a solution, pi over 2. So these would be our 3 answers here. So in the next part, we're simplifying our trig identities. This is going to be given to you on the test. And then it's important to know that with your reciprocal identities, these can be flipped. So we could say that sine of x equals 1 over cosecant. We know that cosine of x equals 1 over secant. So these are given to you, but it also works when it is flipped. So you can flip the sine and the cosecant, or the secant and the cosine, or the cotangent and tangent. So tangent of x equals 1 over cotangent. So the flip of them work too.
You can't look like the tan.
Right. And then our Pythagorean identities, anytime we see something squared, especially if it's attached to a 1, we want to look at our Pythagorean identities. So if you see something squared, if you're adding or subtracting a 1 to it, you always want to look for your Pythagorean identities. Yeah. So starting with number 1 here. It's pretty simplified already, but we want to simplify it more. So one thing that we could do is change everything to be in terms of sine and cosine. How could I change tangent to be in terms of sine and cosine? What does tangent equal? Sine over cosine. So I'm going to change tangent to be sine over cosine. Then we have over sine of x. What do we do when we have a fraction and a fraction? Keep, change, flip. We're going to keep the top, change to multiplication. When I flip the bottom, what does it flip to? 1 over sine of x. Now, if we're multiplying, and we have the same thing on the top and the bottom, they can cancel. So we can cancel out the sines. So what are we left with?
1 over cosine.
1 over cosine. And what does 1 over cosine equal?
I think secant.
Secant. 1 over cosine equals secant. So our answer would just be secant. What could we do with number 2? Any suggestions?
Oh, can we flip cot?
To what?
Cosine x over sine x?
We could. So cotangent, we can make it cosine over sine. That works. We can make secant 1 over cosine. We can definitely do that. So here up top, just looking at what we have up top, I have cosine over 1 because it's kind of like a whole number there. When I'm multiplying, if I have a cosine on the top and the bottom, what could we do? They can cancel. So what are we left with up top? 1 over. We still have the cosine over sine on the bottom. Now, what could we do if we have a fraction and a fraction? Keep, change, flip. I'm going to do that down here so we have some more room. Keep, change, flip. I'm going to keep the top, change to multiplication. We flip the bottom to what? Sine over cosine. So when we multiply, 1 times sine over cosine would just be sine over cosine. What does sine over cosine equal? Tangent. Once you get it down to one trig function, you're done. That's as simplified as we can go. So looking at number 3, we said when we have a trig function squared, especially if it's attached to a 1, we want to use our Pythagorean identities. So which of our Pythagorean identities involves secant? This one. So we know that tangent squared x plus 1 equals secant squared. So how could I rearrange this equation to make it look like secant squared minus 1? What could we do to rearrange our equation here to make it secant squared minus 1? Subtract the 1. So we have tangent squared equals secant squared minus 1. So I can replace the secant squared minus 1 with what? What does secant squared minus 1 equal? Tangent squared. We're going to replace that with tangent squared. So we have tangent squared over secant squared still. What could we do next?
Do you have to change secant?
To what?
To... change it to 1 over cosine, right?
We could do that. Let's change everything to be in terms of sine and cosine. So what would we change tangent squared to be?
So you change that to sine over cosine.
But instead of just sine over cosine, we'd make it sine squared
Cosine
over
squared.
cosine squared. And then over secant squared would be what?
That would be 1 over cosine squared.
1 over cosine squared. So just change the top to that and the bottom to that. So when we have a fraction and a fraction, we can keep change flip. So keep the top, change multiplication. We're going to flip the bottom to cosine squared over 1.
And you cross them out.
If you're multiplying and you have the same thing on the top and the bottom, they can cancel. And what are we left with?
Sine squared.
Sine squared. That's it. 195 is not on our unit circle, but we want to find two numbers that either add or subtract to 195 that are on the unit circle. So what two numbers on the unit circle add or subtract to 195?
45 and 150.
Awesome, 45 and 150, so 45 plus 150. Now going to our sum and difference formulas up here, the one that goes cosine plus, the cosine where we're adding, is the third one. So we're going to use this part of it.
We're gonna have that formula, right?
Yes, but if you ask me again, the answer is going to be no. I don't know how many times I have to say it. So the first numbers are S, the second numbers are T. So our formula goes cosine of S times cosine of T. So cosine of 45 times cosine of 150 minus sine of 45 times sine of 150. So once we plug it into the formula, we're plugging it into the right side here. We're going to look at our unit circle. So I'm going to go to 45 degrees on my unit circle to find the cosine of 45. Cosine tells us we look at what? The x value. So what's my x value at 45 degrees? Square root 2 over 2. So square root 2 over 2. Then we're going to find the cosine of 150. Cosine tells us we look at the x. So I'm going to go to 150. What is our x value at 150? Negative square root 3 over 2. Then minus, let's do the other side. Sine of 45. Sine tells us we look at what? The y value. What is our y value at 45 degrees? Square root 2 over 2. And then go to 150. Our sine, we look for the y value. What's our y value at 150? 1/2. Now we're going to multiply and then subtract. So when we multiply straight across here, what is square root 2 times negative square root 3? Negative square root 6 over 2 times 2, which is 4, minus square root 2 times 1 would just be square root 2 over 2 times 2, which is 4. So when we combine these together, we get negative square root 6 minus square root 2. Those are not like terms. You cannot combine them, over 4. So that would be our answer. So we just combine it because we have a common denominator, but you can't actually add the tops together because they're different radicals. So with number 3, we're given the right side of one of our equations. We're going to use the left side. So which equation goes cosine, cosine, plus? So looking at our equations here, which one goes cosine, cosine, plus? The last one. Here it goes cosine, cosine, plus. So we're given the right side, we're going to use the left side now. So we have cosine. The first numbers are S, the second ones are T. So cosine of 200 minus, because our formula says minus now, so minus 80. So cosine of 120. Now this is the first part of the question. it's going to say, to simplify it to one trig function. So this would be our single trig function. So this is one answer to the question. The second part of the question is going to say evaluate. So we're going to go to our unit circle and find 120 degrees. So our 120 would be here. Cosine tells us we look at what? The x. What's our x value? Negative 1 over 2. So when we evaluate, our answer is negative 1 over 2. So there's two parts to this question. It'll say write as a single trig function and evaluate. So you got to do both parts.